All right, we're ordering these from widest to narrowest. And remember, you have a parent function called x squared. Okay, y equals x squared, or another way to say it is uh, f of x equals x squared. And you actually see f of x equals x squared. This is like the parent function that uh, we're going to be playing off of, right? Or we're going to be manipulating every time we put in numbers different than just the simple y equals x squared, but we put a coefficient in there or an x term or constant. That's going to manipulate the parent function and its graph in very predictable ways. So, um, what's the idea here? Well, here's the idea. If you had some set of numbers, I'm going to just make a graph over here on the side, just like a sketch. Okay. Let me use the line tool. So let's say this is the coordinate grid. Okay. And we're going to make a graph. Let's say we were going to graph in pink y equals x squared. And it looked like that. Okay. Well, if you took 5x squared, what you're basically saying is, and I'll do it in, let's say, blue, okay, that for any given x value, what you would normally get out, like let's say you go over here to 1 for x, and you would normally go up to 1, right? 1 squared is 1, and that you'd be up there at 1 comma 1. Well, if you have a 5 in front, that's going to say, well, if you go over to 1, right, plugging 1 in, you square 1, it's 1. But then if you multiply the answer by 5, you're going to move way up, 5 times higher. And we're going to plot a point up there. Right? We've still got that 0, comma 0 right there. All of these are going to go through 0, 0. But then, so now what about 2? Well, if you plugged in 2 and you squared it and you got 4 and you were up here, that would be normally up here at 4. But now you're going to multiply by 5 because this is 5x squared, not just x squared. And so you're going to take that 2 squared is 4 and multiply it by 5, and now you're going to go way up there, okay? And the resulting graph is going to be like this. It's going to be stretched upward. And the way we would describe that is it is narrower, because here's the idea. For any particular point that we are up, like which one is closer to that line of symmetry, closer to the center. So for this value of y, the blue one is narrower. It's not as wide as that pink one is at that y value. Okay? In fact, the way that we're going to determine this ultimately is this. Did you hear this? The bigger the coefficient that's in front of that x squared, the narrower it's going to be, because the higher you will put every one of those points up for any given x value. Okay, so the a in front of the x squared, that coefficient of x squared, the higher the number, the more it's going to be stretched upward, and the narrower it will be. It doesn't matter whether it's positive or negative. Okay, negatives will flip it over, and I'm going to do so. What I did there when I graphed that just now, I graphed this one in blue. I'll underline it in blue. I graphed that one. More or less, I sketched it, right? I didn't really accurately draw it. But let's do it for the negative 3x squared. Well, it's going to start at that vertex point again, and it's going to now go down instead of up, but it's still going to be a little bit more stretched than what the pink one is. It's still going to be narrower. It won't be quite as narrow as the blue, because what we really want to look at is the absolute value of the coefficient. So, and that was that, right? So when I say absolute value, what I mean is this one has a 1 in front of it. This one has a 3 in front of it, because we're only talking about how much you stretch it, not in which direction. The negative is whether you stretch it down or stretch it up, right? That's where it's opening down or opening up. But the 3 itself means it's going to be, each point is going to be 3 times higher above than its parent function. And this one is even more. That's a 5. So that's going to get stretched the most. So if I wanted to draw this again, and I'll try and draw it again to make it a little bit more exaggerated, let me erase these points. And, oops. me erase those points and sketch it again a little bit more exaggerated so you can kind of hopefully see it. Okay, I'm going to do the parent function in pink because that's what's underlined over there. Okay, and let's say that that looks like this. Oh, let me try it again, like that. Okay, then -3, because 3 is bigger than 1, it's going to be narrower. That will be then green. And even though it'll be opening down, it won't be opening, it'll be opening less widely, right? It's going to kind of do that. It's less wide. And 5x squared, the one underlined in light blue, that's going to be narrowest of all. So it's going to do something more drastic, more narrow like that. Okay? So regardless of whether it's opening up or opening down, what you're saying is for any given distance from the vertex, how wide is it? Okay, and for that one, let's say it's that wide. This one, for that same distance from the vertex, it's really narrow versus this one, which is pretty wide. Okay, that's the idea. So we're going to do that without actual, we'll order these. Give me just a second. Let me erase all of these marks. And we'll put these in order. And then we're going to do the same thing without actually trying to make a sketch of them. Okay. Oh, and let me get rid of all those marks too. I'm sorry for the delay here as I talk at you and I'm erasing stuff. But remember, they're asking you to say, what's the widest? And the thing that's the widest is going to have the lowest, the coefficient closest to 0. And this one, 1, let me see if I can cut that out. F of x equals x squared. That's the widest because it's got the smallest number in here. I'll put this here, right? Closest to 0. Number closest to 0 means widest. And then we'll order, what's the next one we're going to order? We're going to say this one, further from 0. How many units from 0 is that? That's 3 units from 0. The one that I wrote, the first one, 1x squared, that's 1 unit from 0. This is 3 units from 0, even if it's in the negative direction. And finally, oops, oh my gosh, it's not working. This one is the furthest from 0, and so I can say furthest from 0 means narrowest. So that's the order of those. And let's do that again for this last one, for number 19. Okay, which number is closest to 0? Well, negative 2/3. Oops. Negative 2/3 is closest to 0. That right there. So that one is going to be the widest. It's closest to 0. Okay, this next one, let's see, -2, that's 2 units from 0. So I'm going to crop that out and put that next. And then finally, furthest from 0 is -4. That's 4 units from 0. So I'm going to crop that out, put that there, and that is from widest to narrowest. Sorry for the marks there, but that's how you do it. That's the answer.